So in order to add or subtract fractions, you need to have a common denominator. Can you see? Am I blocking you? You can see? Okay. You need to have a common denominator. So my LCD is going to be both of these factors. So I need to make sure that my answer has both fractions. That's my LCD. LCD stands for least common denominator. So what that means is I'm going to take my first fraction. Let me go ahead and rewrite it and give myself a little bit of space. In order to get my common denominator, I have to multiply the first fraction by what it's missing, which is x plus 1, and the second fraction by x minus 2. So now we're ready to make our fraction. This is my denominator. And we just go straight across. I want you to write everything that you see I have highlighted in that order. 3 parentheses, x plus 1, minus x parentheses, x minus 2. That's what you're going to write on the top. So next we need to distribute. So this first parentheses, I'm multiplying it by 3, which is going to give us 3x plus 3. The second parentheses, I'm multiplying by negative x. So negative x times x is negative x squared. Negative x times negative 2 is a positive 2x. And that's all over my denominator of x minus 2, x plus 1. And then our last step would be to look for any like terms. And we do have 2 like terms. We have this 3x and the 2x that we can add together. So my final answer is negative x squared plus 5x plus 3. And that's all over my LCD. And that would be your final answer. Any questions? All right, we're going to go to our notes. Page 10 in our notes. So I'll give you a second. Okay, so we got our notes out. So the last time we had an asymptote, we graphed 2 different functions that have asymptotes. The first function we graphed was an exponential, and that had a horizontal asymptote. And then we graphed a log, and the log had a vertical asymptote. But now we're graphing a rational, and a rational has both. So when we graph our rational functions, we actually have 2 asymptotes. We have a vertical one and we have a horizontal one. So we're not going to focus on domain and range. We can put that away. Yeah, we're not going to do that. So, do you all remember AH and K? AHK? Well, it's back. So, write down that your vertical asymptote will be at x equals h. Your horizontal one will be at y equals k. So okay. So A is always in the numerator. So A is in the top. And A will, if it's greater than 1, so if A is a big number, it's going to make it stretch. If A is a small number, between 0 and 1, it's going to make it compress. And lastly, if it's negative, it makes it reflect. So it has 3 superpowers. So it can stretch it, compress it, or reflect it. So stretch it, compress it, and if it's negative, it reflects it. H is going to be the number that you see in the denominator. Let me zoom in. This is H. Now remember, H, you always have to flip the sign. You always flip the sign, and that's what a lot of students forget to do. But H moves the graph left or right. That's what the H does. So now we talked about the fraction. So now if there is a number outside of the fraction, either in front of the fraction or behind the fraction, that's K. K will move the graph up or down. So let's practice writing down some transformations. Let's look at this fraction here. I had a bruise. All right, so A is in the numerator. This is A. That doesn't change anything. H is in your denominator. What do you think H is? Positive 4 or negative 4? Negative, because we flip it. And that makes the graph go left 4. I'm going to pause right there. Your vertical asymptote comes from H. So we're going to write x equals negative 4. Whatever you put for H is also your vertical asymptote. And then your K value, that's in the back. That's negative 3. Kind of ran out of space. That moves it down 3. And that also affects your horizontal asymptote, y equals negative 3. All right, I want you to take a couple minutes and try to do the second one, and then we'll go through it together. And while you're doing that, I'm going to pass out the homework. I forgot to tell y'all to pick up on the way in. So this is homework 3. It's due on Thursday. Oh, you picked one up? Okay, anybody else pick one up? You did? Because I forgot to write one. You got one too? All right, who didn't get one? Raise your hand if you didn't get one. Get that back. All right, keep your hands raised if you need one. Anybody over here need one? So everybody got one now. Okay, good. So y'all picked it up without me saying something. Wow. All right, go ahead and finish out B. Just take a guess. Write your A, H, and K. And then we'll fill in what they do. Right. All right, so what did you put for A? A is 3. Did that make it stretch or compress? Who says stretch? Who says compress? If it's bigger than 1, it stretches. And do you agree that 3 is bigger than 1? So because 3 is bigger than 1, it's going to make it stretch. All right, H. Jaden, what you put for H? Did you put +1 or -1? +1, because we have to flip the sign, and that makes it go to the right one. I did not mean to put X equals 1. I'm sorry, y'all. H equals 1. And that's going to move it right 1. Now, that does control your vertical asymptote, so I'm going to put X equals 1 here, because that's the equation for my asymptote. And I don't know if I'm writing big, but I do not have enough space. All right, and then the last thing is our K. So, Sean, what did you write for K? So, K is the number that's not in the fraction. So, what number is not in the fraction? 6, and that makes it go up 6. And that would be your horizontal asymptote. And that's it. That's your transformation. I don't know. Do we have that in the homework? No, we don't. All right. So when you're looking at a graph, these dashed lines, they're actually called asymptotes. So the horizontal goes left and right. So my horizontal asymptote, you always start horizontal with y equal, and vertical starts with x equal. Let's start there. So my horizontal asymptote, let me zoom in. Where does it cross through the y-axis? What number did I just circle? 1. So that means that your K value in this equation would be 1. You have a horizontal asymptote at y equals 1. And then straight down vertical, where did that go through the x-axis at? Show me with your fingers. What number? What number is it going through the x-axis at? 2. So that would be x equals 2. All right, so we're going to do a couple graphs. If you have like a color pencil or a highlighter or something, it might be helpful because I do a lot of coloring. Not a lot, but a little bit. So if you have one, if not, then it's okay. We can still roll. So let's go ahead and get started. So the first thing we're going to do, we're going to graph two graphs, and then we'll be finished. The first thing I'm going to do is find my A, H, and K. So A would be 1. What is H? +3 or -3? And that's going to make it go left 3. So I'm going to write that down. And it also means I have a vertical asymptote at x equals -3. So let's draw that in right now. So I'm going to find -3. And then I'm just going to draw a line, a dashed line that goes through only at -3. That's called an asymptote. An asymptote is an invisible line that the graph has that it doesn't cross or touch. So if you have like a highlighter or something, you can use that to trace your asymptote. If you have one. If you don't, don't worry about it this time. But you can do it all in pencil. Yeah, you can trace it if you want to. Okay, so then your K value would be -4, which means it's going to go down 4. And my horizontal asymptote would be at y equals -4. So I'm going to find -4, and I'm going to draw a horizontal line right there. All right, so this is where I need everybody's attention on the board, because this is where it kind of gets confusing a little bit. But I'm going to try my best to go really slow, because graphing a rational does not require a table.
Everything else we graph, we had to make a table. We had to add the age and multiply y by a and add k. We do not have to do that for a rational. So what I just did when I drew in my asymptotes was I divided, and you don't have to just look at the board. I divided this graph into 4 sections. That's what the asymptote does. Is it divides your graph into 4 sections. We're only going to use 2 of those sections, and that depends on the a value. So when a is positive, I'm gonna go ahead and draw in my little. When a is positive, we use these 2 sections. When a is negative, I use these 2 sections. So when you have your asymptotes, let me draw that on the board back here. After you draw in your asymptote, it divides it into 4 sections. So you have 2 asymptotes. This is plus, minus, plus, minus. Okay, that's number 1. So what is a? In this equation, is a positive or negative? Positive. So that means that when I graph, I'm only going to graph in the purple and blue area. So everybody look at the board. The purple and blue are positive. So I'm going to cross out these sections that are negative. I'm going to color it in because I'm not using that. We only use the positive because a is positive. A determines where we put our graph. Exactly, yep. If a was negative, we would cross out the positive. So I'm going to cross this out, make sure it's really good and crossed out. So my graph is not going to be anywhere in these areas. Okay, so now I want you to put your pencil where your asymptotes cross, which should be right here. Put your pencil right there. The a value tells you how far to hop up, down. You always just hop in once. So from here, because a is 1, I'm going to hop up 1 and then go inside. Go inside the area. So I want you to go. Put your pencil here. Because a is 1, hop up 1, put a point right there. And then put your pencil back here. Hop to the right 1 and go inside. And when a is 1, it's always at the same place. So I'm going to put a point, 1 point in my positive. So when a is positive, you only have 1 point that you're putting down. So a is positive. Let me zoom in and put a point right there. So now I want you to put your pencil here because we got to put something down here. We're going to do the same thing. Coming from here, I want you to hop to the left 1 and then go inside. Put a point right there. Coming from here, I want you to go down 1 and put a point inside. So there's only 1 point that we have. And to finish out our graph, I'm just going to make a graph. It looks like it's really close to the horizontal asymptote, and then it goes down. Then over here, it's coming straight down. Remember, an asymptote is like a boundary. And that's your graph. That's all you have to do. Why did I spell down wrong? What am I doing? Let me fix that. Down 4. Okay. So we're going to do one more. I feel like when a is 1, that's a little confusing. We're going to practice this a lot next week. So let's do another one. Yep. So let's do another one. One more. So the first thing we're going to do is identify a, h, and k. So a is 2. It's positive 2. H would be positive 4, which means this graph is going to go right 4. And I'm going to draw in a dashed line at x equals 4. So pick up your highlighter. I want you to draw in a dashed line at x equals 4. And then your K value, what is K? What'd you say, Juan? Positive 2? Yep, K is positive 2, so that means it's going to do what? What is that going to make the graph do? Go up 2, and you're going to draw in a horizontal asymptote at y equals 2. Okay, so now we have my graph divided into 4 sections. So let me go ahead and color in my 4 sections. So I got this section, and then I have this section, and then I have this section, and then I have this section. Now, because A is positive, in what 2 colors do you think I am going to graph? Am I going to graph in the purple and yellow or in the pink and blue? Pink and blue, because that's the positive area. So I'm only going to graph, because remember, it goes plus, minus, plus, minus. So I'm going to color in my negative area. So this part I am not using. I'm going to color that in. Not using that part. So now let me zoom in really close. I'm going to zoom in. Where these 2 asymptotes cross each other, I want you to take your pencil. I want you to put it where they come together. But what was A this time? 2. So I'm going to hop up 2 and then go inside. You only go inside 1 time. So let me go here. Because A is 2, now I'm going to hop up 2 inside, put a point right there. Let me do that again. Everybody's eyes up here. Because A is 2, now I'm going to go up 2 and then go inside instead of up 1. The last one, A was 1, so I only had to go up 1 and then I went inside. But this time, A is 2, so I'm going to go up 2 and then go inside. If A was 3, I would go up 3 and go inside. But A is 2, so everybody's eyes up here. Put your pencil where they cross. Hop up 2, go inside, put a point. So everybody should have a point in their graph right here. Then I want you to go back to where they cross. And I want you to go right 2 and go inside and put a point. So everybody's eyes up here. Where they cross, go right 2 and then go inside. And when you're going inside, you're only hopping in 1 step, not 2 steps. So you're going to take 2 steps to the right and then take 1 step up. It's always 1 step to go inside. So your second point should be right here. We're going to repeat that process in the other side that's positive. But this time, I'm going to the left 2. 1, 2, go inside, put a point. So everybody's eyes up here. Where they cross, left 2, go inside, put a point. So then we got another point right here. Then we're going to repeat that one more time. Where they cross, what direction do you think I'm going to go down or go to now? I told you down. So go down 2, go inside. So you're going to go down 2, go inside. So when you're graphing a rational, they're really, again, it's a pattern. So now when I graph it, I'm going to come in and I'm going to cross through both of those points, and then I'm going straight down. That's it. I'm going to do the same thing over here. I'm going to come down, cross through both of those points, and go straight out. To me, it looks like a butterfly. I don't know why. I think I'm the only person that sees a butterfly, but that's what I see. Yep, if it looks like that, you're good. That's it. That's how you graph a rational. So I'm not asking you if you could take a test tomorrow, but thumbs up, sideways, down. Did you follow me with my process? Did you understand the process? Okay, so we're going to practice this a whole lot next week. Everybody has homework. I would recommend that you at least start. If you don't do anything else, first of all, the homework is due on Thursday. You also have a skills check that's over graphing on Thursday. But if you don't do anything else for numbers 4, 5, and 6, at least fill in your horizontal asymptote, your AH and K, your vertical, like all of that. You don't have to worry about graphing if you still need practice with that. Now, right now, we cannot do number 7 because 7 is different. Okay, so use this time. You can try to work through as much as you can. And that's it. I'm going to continue grading.